there is modified IRR, and we'll see how it works. And modified IRR actually addresses some other reason, but the reinvestment rate assumption is one important point about IRR to stick on. Now, MIRR is the discount rate at which PV of project's terminal value is equal to the PV of costs. And terminal value is found by compounding inflows at WACC. In other words, if we have this 70, 50, and 20, we will compound them, we will take them to the last year, and our last year was year 3. We will take all this together, we will call them terminal value. In case these are all positive numbers, if somewhere in between we have a negative number, we would take that negative number to present value. So the rule is all negatives to present value, all positives to terminal values. And by this, we have now 2 numbers. We eliminate any intermediate numbers, which means there is no need to reinvest them. We already, by compounding to terminal value, we already reinvested those numbers, but instead of IRR, we reinvest WACC. So we take 10% instead of 23 or 18 or any other number. And by this, we will get more conservative number, lower number, if IRR is higher than cost of capital. Now in Excel, life is easier. Instead of IRR, you type MIRR, and we'll do it shortly. You see, you have to choose the range A4 to D4, and then Excel will ask you 2 rates. One is financing rate, the other one is reinvestment rate. In both cases, you input cost of capital. Theoretically, they can be different, but you don't need it. In both cases, you refer to B4, and you get 16.8%. On the paper, it looks like this. What I draw, now we have the numbers, 66. So we have, I think, long project instead of short one. So the terminal value of 80, which is itself, and then 60, which comes to 66 at 10% compounding, then 12 for this 10, terminal value is 158, and present value is 100. Again, if we had any minus number, let's say if this was a minus, then we would bring it to present value rather than to take to future value.